Hello my dear ones. Right now we are going to learn some characteristic features of polynomial functions. So you see the general standard form of the polynomial function. This is how it goes. X to the n starts with x to the n, which is called the leading coefficient, and there is x to the n minus 1 and n minus 2 and so on, which means that the consequent terms are going to be 1 degree or 1 power or 1 exponent less than the previous one. And normally the coefficients of each term, if you call the first or the leading term a sub n, then the next one would be a sub n minus 1 and so on and so forth. All these an's, all these a's or the coefficients are real numbers, okay? But there is one catch. You may not have a fractional exponent or a negative exponent. I'll take back with the fractional exponent, but there cannot be a negative exponent, meaning you cannot have something like 2 over x. This cannot be a polynomial according to the polynomial function's definition. Which usually shows up as x to the n minus 1. In this case, 2 times x to the n minus 1. So x to the negative exponents are not allowed in polynomial functions. So in Math Excel, you'll see some questions like that where he'll have negative exponent and we would not select that as a polynomial function. Okay, so normally, since they are not rational functions, the shape and the continuity is that they are smooth curves, smooth curve without breaks, which means they are continuous. So they're continuous, right? So, and one more vocab word, degree is the highest exponent or the greatest exponent or the greatest exponent n of a polynomial. In this case it is n, isn't it? That's how we are calling it as. So these are the basics, and then we'll move on to different examples. Even before we go to this, you should already know by now that excuse me, this has its own mind. A monomial is a polynomial with just one term. Just one term. A binomial is a polynomial with 2 terms. And a trinomial is a polynomial with 3 terms. And then consequently we call, if you have 4 terms or above, you'll say a polynomial with 4 terms and so on. But specifically monomial is 1 term, binomial is 2 terms, and trinomial is 3 terms. If you see just a number here, this is still called a polynomial, for example, because if you could consider this as 2 times x to the 0, a 0th power, because anything to the power of 0 is 1. So this is technically a 2, but you could write it as 2 times x to the 0, and so the degree of that polynomial would be 0, and we would call that a constant, right? And then if you have a degree 1 or x to the 1, then we call it a linear function, isn't it? If you have x squared, then it's a degree 2, and you will call this a quadratic, right? If you have 3 here, x cubed, then it's degree 3, and you will call that a cubic function, okay? And if you have x to the 4, it's a degree 4, you call that quartic, a quartic function. And x to the 5 is degree 5, and you call that a quintic. Oops, that's an n. A quintic function. A quintic function, okay, and so on and so forth. So now this is the most important part, the end behavior. So we'll use this a lot, and in normal terms, if you see, now this is an example of a quadratic, right? It has an even power because 2 is an even number, and also if you watch, the sign before it is positive, which means it has a positive coefficient, right? If it could be 1, it could be 2, it could be anything, but anything above 0, of course not 0. So if this is the case, then you will see that the graph is going up in the x on the left side of the x-axis and the right side of the y-axis, but mostly, basically, it is both ends of the graph are going up and up, right? So the math way of saying this is, as x approaches positive infinity, this is the positive infinity, right, on the x-axis, and this is the negative, isn't it? So as x approaches positive infinity, what is y doing? The graph is going up, meaning all the y values are going positive. So that means f of x approaches positive infinity, right? As x approaches negative infinity, what happens when the graph is going on the left side? It's also going up. The values of the y are still going positive, in the positive direction, right? So that's what you have to remember. This could be generalized for any even-powered polynomial or even degree polynomial. What if the coefficient is negative? Now, this is still a quadratic, it is even-powered, but it has a negative coefficient. Then the graph would be reflected over the x-axis, isn't it? So, which means that it is going down. Both ends are going down and down. So how would you write that? You would say, as x approaches, now we'll do the negative side first. There's no hard and fast rule which should be written out first. As x approaches negative infinity, f of x approaches negative infinity. And as x approaches positive infinity, f of x is still going down, isn't it? F of x approaches negative infinity. So I hope you're getting the idea by now. You can now actually pause the video and see what happens for the next two. So now this is a cubic function, so it's odd powered, right? And the coefficient is positive, right? So if you see here, one end is going down and the other end is going up. So you will actually see the left side first and then go to the right side. So what happens when the x is going to the negative infinity, right? And this is going to the positive infinity, right? So as x approaches negative infinity, f of x is approaching negative. And as x approaches positive infinity, f of x is actually going positive, up, right? So, and when you have a negative coefficient for an odd power, right, then it is going up and down. So here you would see as x is approaching negative infinity, f of x approaches negative infinity. Am I right? No, it's going positive actually. It's just checking, right? So as x approaches positive infinity, f of x approaches negative infinity. So this is an important information, and as you go into questions like Math Excel, you will see, you will look at these, and I'll covered them up in some other video, or maybe if possible in this video. So, but these are good examples. Now you have seen the examples now. Now this is an even powered, right? And the leading coefficient is negative. So we saw that for the graph which has a quadratic, negative x squared, the graph is reflecting over the x-axis. So you could use the same thing here and say both are going down. Both ends are going down. So how would you write? As x approaches negative infinity, f of x approaches negative infinity, and as x approaches positive infinity, even then f of x approaches negative infinity. Okay, so that's how this one goes. So if you have fourth question here, now this is odd power, and it has a positive coefficient. You can scroll up and see odd power and positive coefficient. So the left side is going down and the right side is up. So you can use the same thing here. So here, as x approaches, so it is down and up, by the way. So as x approaches negative infinity, f of x approaches negative, and as x approaches positive infinity, f of x is going positive infinity, and so on and so forth. Okay, I want you to try the others. Now if you see here, describe the power. Now the graph is given to you. He's asking you to estimate what could be the leading coefficient, leading term. How does the leading term look like? Okay, so here this is positive and this is going negative. So it's down, it's up and down. And this happens only in odd power. When it crosses the x-axis, both ends are not in the same direction. So it's definitely an odd function. So in that case, what do? We would say that it's definitely some odd power, and since this is going up, as x is approaching negative infinity, the y is going up, isn't it? So it must be a negative coefficient also in addition to this. So there is another minute information that you could actually say, that if you count the number of limbs in the graph, so this is the first, this is the second, third, fourth, and fifth. So this is it's a fifth power. So a negative x to the fifth. That's how we can actually estimate the leading coefficient, and there are others coming. So we cannot estimate that as easy. We have to actually look at the intercepts and so on and so forth. But it will end up, you will end up getting x to the fifth. Now here if you see this graph, both are going up, so it must be looking like the quadratic function going up, isn't it? So both are going up, so it must be an even powered with positive coefficient. This is positive. So if you count the number of limbs 1, 2, 3, and 4, it's definitely an x to the fourth and with a positive coefficient, and there will be many more coming. So this is a quick run through the first part of the lesson for today, and we have a little more detail to talk about, and then we'll go to the Math Excel questions. I hope you have enjoyed this video. I'll see you in the next one. Thank you for watching.